What do you think about these two things? A to the power 1 over n and nth root of a. Are these two equal to each other? So today I am beginning lesson 5 of pre-calculus series. So here I will discuss how to simplify expressions containing rational exponents, and also I will talk about the relationship between these two. So please keep on watching this video to learn that. Hello everyone, welcome back to Dona's Academy. Alright, so I'm beginning lesson 5 today. I'm going to talk about how to simplify expressions containing rational exponents. So far we discussed a lot of lessons that related to this topic. Simplifying expressions and simplifying radicals. So please watch those lessons if you haven't watched them before. I have copied the links below, and I have you can see the iCard for lesson 4. All right, so rational exponents. So first of all, let me remind you what a rational number is. So rational number is always a number of the form m divided by n, where so rational numbers where these m and n are integers. However, this n, the denominator, cannot be 0, otherwise it is undefined. Okay, so m and n are integers, n is non-zero, and these m and n should not have common factors. So if a given number is of this form, then it is called a rational number. So for example, all integers are rational, and other fractions like 1/2, 2, 3, 4, 5, all others of this form are rational numbers. Okay, now we know what a rational number is. Now let's think about, first of all, let's think about the relationship between rational exponents and nth roots. Indeed, they are equal to each other. So this is equal to this thing. Exactly, right? Definition. It's a definition. All right, so let me write it. So here are a couple of we have a couple of parts. First, this thing, a to the power 1 over n, is same as nth root of n. However, this should be a real number, right? We know that for some numbers, for example, square root of a negative number, it's not defined, it is not a real number. For that, we don't have this kind of definition. As long as this is a real, we can have this definition. Second one, now if you have a to the power m over n, a rational number, here this is also a rational, but the thing is here the top is 1, so that's why it's special. If we have a general number in the top, then this is same as nth root of n to the power m. And also we can have another form. This is same as a to the power m first and nth root. They both are same. They both represent this thing. Okay. All right. Next, if you think about power of power rules, this is same as a to the power m first and to the power 1 over n. Because if you multiply these two, you get this number. And also you can switch these two. It doesn't matter for multiplication, order doesn't matter. So this format is also okay, because if you multiply these two, you get this thing. Alright, so here are a couple of definitions for expressions with rational powers, rational exponents. It is same as the nth root, and with respect to nth root, we can have these definitions. Alright, now let's think about how to simplify. Let's do a couple of examples on how to simplify expressions with rational numbers, rational exponents. Okay. Alright, so now in similar to simplification of other expressions and radicals, there should be a definition here. The thing is, it is really easy here. Now there is no difference between the definition of simplifying expressions with integer exponents and simplify expressions with rational exponents. They are exactly same. The definition is same. Laws are same. You can use the same set of laws, same set of definitions, and same set of rules, right? So the definition, what was the definition for simplifying expression with positive integers? Not the radical thing, right? Don't mix these things, right? Even though this represent, these two are same. Simplifying expressions with rational exponents, the definition is not same as simplification of radical expression. They are a little bit different. However, simplifying expressions with rationals is same as simplifying expressions with positive integers. Okay. Alright, so you have to follow that definition. Now, what are the conditions for simplifying expressions with positive integer exponents? First one is each real number or each term should appear only once. For example, there cannot be two x's. X can't be in two places. Y can't be in two places. Each term appears only once. And the second condition is all exponents are positive. You can have the same conditions for simplifying exponents, simplifying expressions with rational exponents. All exponents are positive. Alright, so let's use that definition and let's do a couple of examples. My first one is x6 y3 to the power negative 1/3 divided by 6 to the power negative 1/2. Okay, so I can use the same set of rules. You can use power of power rule and everything else. Then if I use that, I get x to the power 6 negative 6 3. Here I am multiplying this by this. Okay, and for y I do the same. I am multiplying this by this. Then I get negative 3 divided by 3. And similarly in the bottom I have this. Alright, now this thing equals x to the power negative 2, y to the power negative 1, y to the power negative 3. Still it doesn't satisfy these conditions, right? We can see y in two places and all of these powers are negative. So let's convert them to positive powers. We can think about this as y to the power 3, right? It is 1 divided by y to the power negative 3. So it is y to the power 3. And the others are 1 over x positive 2. And this is 1 over y positive 1. Now if you combine these two terms, I get y2 divided by x2. Now we see only one x, only one y, and all numbers, all exponents are positive. So this is my answer. If you like, you can keep your answer in this format, right? It's also okay. All right, so you saw that there is no big difference. There is no any difference, right? Any difference between simplification of expressions with integers and rationals, okay? All right, so my next example, 3 times x to the power 5 over 6 and 8 times x to the power 2 over 3. All right, so now we can see 3 and 8, so we can multiply these two together to get 24, and then x to the power 5 over 6 times x to the power 2 over 3. You can see same base multiplication, that means you can add these two exponents. Doesn't matter, they are rationals, you can still use the same rules. Then if you add these two together, what do you get? 5 over 6 plus 2 over 3. To have the common denominator, you can multiply top and bottom by 2. Then you get 5 plus 4 divided by 6, 9 over 6. However, we have common factors in 9 and 6, right? 3. 3 times 3, 3 times 2. So this is same as 3 over 2. So always try to have the simplest form of rational numbers. I think I mentioned it when I was talking about the rational definition of rational numbers. Even though I didn't write it, I mentioned it. So m and n should be integers and they cannot have common factors. Okay, so you should have always the simplest form. All right, then this is same as 24 x to the power 3 over 2. All right, so is it simplified? Yes, it's satisfying the two conditions. We can see only 1x and the exponents are positive. All right, so with respect to rational version, this is simplified. Rational exponent version. However, if your teacher is asking you to convert this to radical form, then what do you get? Now you can use the use these definitions. Maybe this thing. Yeah, second one, this thing compared with this one. Now your m is 3, n is 2, so you can write this as 24 square root of x3. All right. However, is it simplified with respect to the definition of radical simplification? It's not, because if it is simplified, then this number, this index should be bigger than the exponents. However, it's not here, right? So this is not simplified with respect to radical. That's why I told you the simplification definition is not same as radical definitions for rational exponents. You have to compare it with positive integer simplification. Okay. All right. So now how do we simplify this with respect to radicals? Radical, not simplified yet. You know that since you have a square root or 2 here, you may have to have a splitting. You have to split the radicand into 2 pieces like this, x2 and x1, right? Since you have 2 as the index. Then what do you get if you use the radical rules? 2 x2 to x, right? Another thing I forgot to mention, we have to assume, right? We have to assume these x and y's are positive, okay? Because otherwise you have to consider the absolute values when it comes to even indexes. So here I am assuming all x, y's are are positive, right? Unless otherwise specified, you can assume that. Alright, then what is this? This is same as 24x square root x. It doesn't matter if you write 2 or not here. If there is nothing, then that means square root, okay? So is it simplified now? Yes, because this is 2 here and this is 1, so simplified. Alright, so this is the radical simplified version. Did you see the difference? Even though it is simplified with respect to rational exponent version, it is not simplified with respect to radical version, so they are not same, even though you have that relationship. Alright, so if your teacher was asking you to simplify, convert that to radicals and simplify it, then you have to, and then this is the final answer. Alright, okay. Next I have a number. My third example is a number. You have to calculate 125 to the power 2 over 3. Now in this case, we definitely have to use these definitions. Otherwise, we can't calculate it. Alright, so if I use that, then this is same as third root of 125 square. It is same as 125 square third root, but it is complicated because then I have to consider third root of a very big number. So here this is easy because we have to take the square after simplifying this piece. Okay, so that's why I'm using this version. Alright, now the inside is the third root of 125. Now let's think about the prime factors. Since you have 5 at the end, let's divide this by 5. You get 25 and 5. So 5 to the power 3. We have third root of 5 to the power 3 to the power 2. Then what is the inside? It is just 5, 2, 25. 25 is the answer. So if you have a number with rational exponents, then you have to use the nth root definition. Okay, my last example, it is again a number. (32) divided by 243 to the power 3 over 5. Now this is same as fifth root of 32 243 to the power 3. Again, I am using this version. I am not taking 32 divided by 243 to the power 3 and then fifth root, because then the inside of the radical will be very big number and it's hard to deal with that. Now let's think about the prime factors of 32. 2, 16, 2, 8, 4, 2 to the power 5 divided by 243. Now what is 243? Let's divide it by 3, then 81, 27. It's again 3 to the power 5 to the power 3. Now the inside is 2 over 3 to the power 5 and then third power. Now what is this inside? It is same as 2 over 3 and cube. This is same as 8 divided by 27. So this is my final answer. Alright, so we talked about a lot of examples on rational exponents. So I hope you enjoyed this lesson. So if you haven't subscribed to my channel yet, please do it, and like this video and share it with your friends. Have a nice day and stay tuned.